Hello, ladies and gentlemen, Root Beer here, and we're going to be finishing up the Canadian Open paper from 2016 in this video. That's right, we're on the last question, C4. So let's dive in and take a look. Just a quick reminder, of course, we need to write up a full solution for every part of this question. And what have we got here? So two lines intersect at a point Q at an angle of theta. And we're told that theta is between 0 and 180 degrees. We got our little degrees symbol here. A frog is originally at a point other than Q, so other than the intersection point, on the angle bisector of this angle. So there's Q, and I guess we have our angle bisector here, so the frog is somewhere here. Call it F. Okay. The frog alternately jumps over the two lines. So I guess not the angle bisector, but the two given lines, where a jump over a line results in the frog landing at a point which is the reflection across the line of the frog's jumping point. Frog alternately jumps over the two lines where a jump over the line results in a frog landing at a point which is a reflection. So if we were jumping in this line, we'd reflect over here. And then I guess we're alternating, so I guess we'd do the next one. It'd be really nice, like, they could have just thrown the word clockwise or counterclockwise in here. Or a picture would have been nice. Just a little frog, and then his first hop, I guess, and then a second hop. I don't feel like this is worded the nicest, but okay, I think I see where they're going. They're just basically, it's a series of reflections. Reflection. I would guess you don't reflect to here and then reflect back, because one, they're saying alternately jumps over these two lines, which to me suggests we alternate the lines, but also, I mean, you just jump back to where you started. Okay. So I think I figured out how the frog works. The frog stops when it lands on one of the two lines. Can that ever happen? Is that possible to actually land on one of the two? Well, I assume it must. Otherwise, they wouldn't have asked the question. Okay, we'll have some experimentation. Okay, so it looks like all three parts here are concerning this frog here. So suppose we start with an angle of 90 degrees. So right angles everywhere here. Show that the frog never stops. Okay. And then suppose it was 72 degrees, so I guess one line and then a 72 here. Show that the frog eventually stops if it's 72. And then C, determine the number of integer theta values for which the frog never stops. Okay. Okay. So, I think if the frog never stops, then we should be able to sort of find a cycle. Like you jump here, and you jump here, and you jump here, and you jump here, and maybe you jump back to the start this time, or, I mean, I suspect that'll happen for 90 degrees just because of the symmetry, but maybe there are other ways where you jump here, and then you jump here, and then you here, and then here, and you sort of form a cycle, and then suddenly you get back to here. I feel like that is a never stops. That would be a good way to show something never stops. Some cyclicalness. To show that the frog eventually stops. Okay. Alright, well, let's just sort of wet our whistle a little bit with the 90 degrees. So, if theta is 90 degrees, and just because they didn't include a picture doesn't mean we can't include a picture, the angle bisector I think it's probably going to be helpful to always draw one of the lines as though it's the x-axis. But the angle bisector here is going to be 45 degrees from both sides. So we'll say it's at 45 degrees to the lines. Okay. So if we're 45 degrees and we say reflect in this line, how does reflection work? Well, whatever angle you made with the line you're reflecting in, that's the angle you would make once you've reflected. So we go from 45 degrees to 135 degrees. But of course that also has an angle of 45 degrees with both lines. And so I think, so reflecting, or reflecting, not reflection. Reflecting, I don't know, I want to phrase this right. Like, a picture is fine, but, oops, don't have the pen tool anymore. There we go. Picture is fine, but I want to be a bit more precise. So I'm gonna actually sort of codify this and say, suppose one line is x-axis. Let's measure the angle the frog is at in degrees measured counterclockwise from x-axis, and we'll say around the origin. So I guess we could say frog starts at 45 degrees, reflecting or I guess I keep saying reflection, or I keep writing reflection despite saying reflecting. So reflecting in the other line, which we can remind them is the x-axis, moves frog to 135 degrees. And of course we can remind them that this is because we start at 45 degrees plus it's 2 copies of the angle that your line is at. I feel like this might be useful. This is sort of how reflection works. In general, if I'm at sort of sigma, and the line that I'm reflecting in is at tau, where the angle that I'm going to be at when I'm reflected is just going to be this, which is 2 tau minus 2 sigma plus another sigma is just minus a sigma. Okay, so that's why it works this way. So that's why we get 2 times 90 degrees minus 45, 135. So this is again 45 degrees between the 2 lines. Now, is it enough to just say this is going to repeat? No, I think what we should do is, because what's going to happen in this case at least is we're going to go 45, 45, and we're actually going to get a cycle, because the next one we're going to go down to is going to be 225 and then 315. Yeah, just add 90 each time. Okay. So next, the frog reflects in the x-axis. So this is reflecting in, I guess we could say, the line 180 degrees. So it moves to 2 times 180 degrees, because this comes from the x-axis, minus 135 degrees, current frog angle, and that'll be 225. Yeah. Degrees. frog then moves again to reflecting in the line 90 degrees, although yes, technically it's 270 degrees now. 2 times 270 degrees. I don't like how big these numbers are getting, incidentally. But that should be 315 degrees. Just let's double check. That'll be 450 minus 22. So that'll be 32 and then minus 5. Yeah, okay, that works. And finally, across the x-axis again, which I guess would be 360 degrees now. So 2 times 360 degrees minus 315. That's going to end up being 360 degrees plus the difference between 360 and 315 is 45. So that'll be 405 degrees. But of course that's the same thing as 45 degrees because there's 360 degrees in a circle. I feel like we might end up working sort of mod 360 degrees or something like that, because otherwise these numbers are going to get too big. Because remember, we don't really use our calculator for this. So, back to starting angle. And we could probably just get away with saying the frog will repeat this pattern forever. Since he never having never landed on either of the lines, having returned to his position, and I suppose by noting that only your current, or I guess only the frog's current position, determines where his next position will go. Okay. It's interesting, the lines sort of split it up into quadrants of a sort, and once we pick that we're heading counterclockwise, I guess is how I keep doing this, because they didn't actually specify clockwise or counterclockwise or anything like that. But once the only thing, once you're in sort of this first quadrant, of course you're going to have to flip over to this next spot. So the line that you're flipping in is chosen for you, I guess, depending on what quadrant you're in. Once you've chosen, is the frog going to start going clockwise or counterclockwise? Okay, so I guess the frog doesn't really stop there now. One thing we could do, now B and C both are sort of asking for similar things. In B we're showing that the frog eventually stops, so eventually lands on a line. But in C we want to determine, well, I guess we're just determining the number of integer values. And it might be conceivable that we can't list all those values out, and that there'd be some reason to show specifically 72 won't work, but I don't know. It might be worth it to try and do B and C together. Although, if you were actually writing the contest and you were a little nervous about C, maybe you didn't learn enough while doing A to try C, and you're running out of time, just trying B might be enough. I suspect that if you start at B, after maybe 3 or 4 jumps, you might actually hit one of the lines, and that wouldn't be too bad. But I think this observation here might be key, and then maybe there's definitely a symmetry of 360 degrees when it comes to this picture, because obviously if you rotate anything by 360 degrees, it stays the same. Although I guess rotating everything by 100 degrees, or sorry, 180 degrees might work as well. And the thetas that we're being asked to choose are between 0 and 180 degrees, so it might be worth it to look at this mod 180, maybe. But I think this formula here will probably get us maybe a pattern if we can ignore the big numbers like 270 and 360. I don't know whether or not it'd be worth it to... I don't think you can do mod 90. No, because the theta value could be bigger than 90. But okay, I'm gonna play around with C just a little bit, and if I can't get it pretty quickly, if I don't see anything that's interesting, I will just do 72, just as though I were actually writing it on a real contest. But so if I got a picture here, and we start at theta, I think I prefer to talk about where the frog starts rather than these angles. So let's say in general, suppose the frog starts at angle, I don't know, we'll say sigma. Well, now phi, I guess, is typically an angle. I just used sigma and tau just because I was doing some algebra earlier, and those were the ones stuck in my head. But phi is usually more common. And angle phi, where one of the lines, so here we have an angle of phi, is assumed to be the x-axis. Now this has to be so since the frog starts on the angle bisector, then theta, the other angle, which is perfectly fine, is 2 phi. But I think I'm going to want to focus on phi because I think more than we haven't really been keeping track of the particular angles for the lines, but we definitely keep track of the frog's position by an angle. So I think focusing on that, and it would avoid this pesky theta over 2 business that might be popping up. Although we will need to remember at the end, it's theta that has to be integers. So I guess we can allow for theta could be 45, and then phi would need to be 22.5, and that's still allowable. So I'll need to remember that when I'm counting things at the end, that it's theta that needs to be an integer, not phi. And so I guess right now in my head I'm weighing the options of, do I want to stick with the theta that they gave me? I really think it's more important to focus on where the frog is, and I think it's probably going to be a lot nicer to have to work with whole integer values of phi's than a whole bunch of theta over 2's. But we'll see where that goes. But something that I am consciously aware of when I do a question like this. I am making a choice other than the one they give me. What are the benefits, and what do I have to keep in mind to keep my answers still in line with their notation? So, okay, theta is 2 phi. Now, since the arrangements of the lines is, let's say, unaffected by rotation by 180 degrees, it suffices to keep track of the frog's angle mod 180 degrees. So, sort of what I'm trying to say here, and you might disagree as to whether or not I've expressed it properly, in which case you would want more writing or less writing. But the frog being here and then hopping over to here, well, if the frog were down here and hopped over to here, that's basically the same as if the frog were up here and then hopped over here. Just we've rotated by 180 degrees. Okay? So this angle that we would have started at, this angle here, they're 180 degrees apart, as are the points that are reflected to. And maybe a picture would explain that a little bit better, but I would say as long as you point out the lines aren't affected by 180 degrees, then the reflections should also be, in which case you just need to keep track of the frog's position. Although, you know, if you were worried about this, you'd probably have an easier sell if you said there's 360 degrees, but I think 180 is fine. Okay. So, reflecting in the x-axis, gives, well, So reflecting in the x-axis from a frog angle of, here I guess I can use sigma, amounts to changing the angle to, it's 2 times the angle of the line you're reflecting in, but it's the x-axis, so we can assume it's 0. Now, earlier in the question we used 180, but remember we're working mod 180, so who cares at that point, minus the angle you start with. So this would just be minus theta. And if you're worried that they're not understanding where these formulas are coming from, you might point out that reflecting keeps angle between point and line the same. I would say a picture is clear, so if I'm reflecting in an angle of tau, and I've got sigma here and sigma here, then, or no, let's say an angle of tau here and an angle of sigma here. Then this is tau minus sigma, this is tau minus sigma, and so my full angle is now tau plus tau minus sigma. We go all the way to tau, and then we go a little tau minus sigma extra. Okay, so that explains where my reflection formulas are coming from, but odds are the person marking is going to be aware of that in the marking scheme. And reflecting in the other line, the theta or the 2 phi line, turns sigma into 2 times 2 phi minus sigma, which is 4 phi minus sigma. Okay, so we go to minus sigma or 4 phi minus sigma. And there we go. So I guess that would be 2 theta minus sigma as well. And that, you know, the numbers might be smaller there. So starting at phi, and moving around the lines, we get, so we start at phi, then we reflect in the 2 theta, or sorry, the theta line, or the 2 phi line, and so that would take me to 3 phi. Then I reflect in the x-axis, so that would take me to minus 3 phi. Then I reflect in the 2 theta, or the 2 phi line. Maybe I should have just stuck with theta. Thought I was being a little clever. So that'll be 4 phi minus this, so that'll be 7 phi. And then minus 7 phi. And then it looks like, yeah, we're just basically adding 4 phi to each one. And then negating it. Okay. So if the frog stops, then one of these, well, actually, we'll say the frog stops if and only if. So the frog stops if and only if one of these values is 0 or 2 phi modulo 180. Actually, seeing these numbers, the 2 phi seems to have worked out, because what would it be? It would be theta over 2 and then 3 theta over 2, and the fractions probably would have been not terrible, but I'm happy actually with the way this turned out. It's good. Okay, so the frog stops exactly when this happens. I'm willing to bet that we could probably stop now and say, okay, well, if theta was 72, then this would be 35, and one of these, or not 35, 36, one of these should be a multiple of 180, I guess. Maybe. Maybe they can't be a multiple of 180, maybe they have to be 2 phi. Well, what do these conditions actually mean? So let's just be clear. So frog stopping here would be a 0. Frog stopping here would also be a 0 mod 180. Frog stopping here would be a 2 phi. Frog stopping here would also be a 2 phi modulo 180 degrees. So, okay. We sort of have two patterns going on. There's this pattern here, which is going up by 4s. And then there's this pattern here, which is going down by 4s. So I'd probably say, notice that the first, third, fifth, so I guess it would be 2k plus first angles are 3 phi, 7 phi, 11 phi. So how are we getting these numbers from 2k plus 1? So how do we get from 1 to 3? 4 times it minus 1? No, because that'd be 12 minus 1 is not 7. It's 2k plus 1, so the k here would be 0. The k here would be 1. 4k plus 1. Multiply by 2 and add 1. Oh, so it's plus 3. Plus 3, my mistake. So 4k plus 3, phi. And the other angles, the 0th, can't forget that one, his starting position. 0th, 2nd, 4th, so the 2kth positions are phi, negative 3 phi, negative 7 phi. So here's k equals 0, k equal 1. 1 minus 4k phi? Yeah, 1 minus 8 is negative 7. Yeah, okay, good. Alright. So we have the frog stops exactly when at least one of these so at least one of, how do we want to say this, 4k plus 3 times phi is congruent to 0 mod 180, or 4k plus 3 phi is congruent to 2 phi mod 180, or 1 minus 4k phi congruent to 0, or 1 minus 4k phi. Now, is there a way to say that in particular certain ones will or will not happen? Like, is it possible that there's no way an odd number jump could have this as an occurrence or something like that? Is there a way to sort of narrow that down? Because at least one of these is kind of a tricky condition to work with. Although I guess we can rearrange them to be all zeros by bringing the 2 phi's over. So 4k plus 3 phi congruent to 0. Subtracting 2 on both sides would be 4k plus 1 phi congruent to 0. We'd have 1 minus 4k phi congruent to 0. And then subtracting 2 would be negative 1 minus 4k phi congruent to 0, right? Yeah, minusing... Yeah, okay, good. Now, there is something we can do here by... I mean, this last one here, all of these, incidentally, mod 180 degrees. But this last one in particular is just 4k plus 1 phi, just multiplied by negative 1. So it's really just this case. And the first and third cases also are sort of the same thing. So, what can we do here? Well, I noticed that for all of these, it's a multiple of 4 and then an odd number. So these are all odd numbers being multiplied by 180. So what we need is 180 to divide 4k plus 3 phi, or 4k plus 1 phi. I'm going to regroup. We'll use we haven't used pink in a long time. I'm going to regroup this and say that this is 4k minus 1 phi congruent to 0, and this is 4k plus 1 phi congruent to 0. But in particular, this top one is 4k plus 1. No, k minus 1? K minus 1 plus 3. Yeah. Phi is congruent to 0. So, as a result, this one and this one mean the same, and this one and this one mean the same. I should think. Maybe there's something to worry about a negative k here, but I think we should be fine. Okay, so that narrows things down, and also, as I remarked, these are odd numbers. Now, 180 is, what? It's 2 squared times 3 squared times 5. Yeah, 4 times 45. Now, these odd terms here, this is 45 here. I suspect there's a way to get... Only one of these could give me 45, but I guess one of them could give me 135? But there's no way they can give me 4. Oh, rats. I just realized I'm making the assumption that phi is an integer. Crud. So... Yeah, this is a problem. So, now it's not too much of a problem because of what I've done. What I would probably do at this point is go back, get rid of this part here, and just replace all my phi's with thetas over 2. Now, the frog starts at theta over 2. And then, while these aren't nice, can we really talk about modulo 180 degrees? Yeah, I guess we can. But if we're going to be talking about integers, I guess we should be talking about theta. So, I don't know, multiply by 2 on both sides, and that should keep... Yeah, that should make everything happy, and now we're at least talking about integers, so got to be careful with that. So theta is an integer. Phi wasn't necessarily. Now we could still talk about dividing by 180 degrees because we still have the symmetry of 180 degrees, but we wouldn't be talking about integers. And now I want to talk about integers and factors and divisions. So I guess we've got an extra factor of 2 over here, but I don't think that's really going to change a whole lot now. If k is equal to 11, 4 times k plus 1 is 45. And if k is equal to, so I want 135, that can be done, right? Yeah, subtract 3 is 132, and that's a multiple of 4. 132, that'd be 25, and then another 8, so that'd be 33. And we'll say, however, 4k plus 3 and 4k plus 1 are odd, so can never be multiples of 2 to the 3, which is 8. And 72 is a multiple of 3. Or, sorry, not a multiple of 3, of 2 to the 3, which is 8. So, I think every odd factor here can be accounted for by sort of hopping enough times, either 11 times or 33 times or whatever it is we need. But you'll only get a multiple of 360 if the theta you started with was 8. So I think we claim the frog stops if and only if 8 divides theta. Okay, so we know the frog stops exactly when 360 divides 4k plus 3 phi, or not phi anymore, theta now, and 4k plus 1 theta for some k. But since the GCD of 4k plus 3 and 2 and the GCD of 4k plus 1 and 2 is 1, then this the frog stopping tells me this, and this statement here implies 8 has to divide theta. And if, so conversely, if 8 divides theta, then taking k equal to, it doesn't really matter, 11 gives 45 theta is a multiple of 360. Do I need the other one? Is it not enough just to have one of these? surely this would... Yeah, I think we just need the 1. I mean, if you feel like you need to add in that the other condition also eventually becomes a multiple of 360, fine. But I think just saying after 11 hops... Well, not even 11 hops, just... one of these will become a problem. I suppose if you're worried about this k-1 thing, maybe you want to say also k equals 33 also gives it. You don't need it, but and so the frog stops. My handwriting has just gotten worse and worse as the video goes on. So for B, 8 divides 72, so frog stops. And actually this also answers A. 8 doesn't divide 90, frog doesn't stop. And for C, we've got 0, theta. Theta's an integer. So frog stops for theta's 8, 16, all the way up to... this guy's a multiple of 4, so subtract 4, 176 should do it. How many of those are there? So frog stops for theta equal all these values, and there are 176 over 8. 8 goes into 17 twice, leaves a remainder of 1, and then goes into 16 twice. So 22 of them, and that's our answer for C. Okay, it took a little while, and I sort of screwed up there by using this 5, but I guess it worked out in the end by multiplying by 2. Would have been nice if they had said something like theta's an even number, then I wouldn't have had to worry so much, but I saved it in the end. I guess I didn't have to write so much to repair that. But I guess sticking with the theta that they gave me would have been probably for the best. But I would have had some ugly theta over 2's there for a little while. And maybe I wouldn't have thought to use modular arithmetic the way I did. I don't know. But yeah, it's a good question. Good paper overall, I found. So if you're looking for more of the Canadian Open, the COMC, of course I have others on my channel. Feel free to look around. I guess the next one after this, if this was the 2016, we'll be going for 2017. So that should get posted eventually, so take a look for that. If you're looking for other written contests, I have lots of contests up, and you can take a look at those. And I will see you for whatever math contest or whatever math video of mine you choose next. Until then, take care and have yourself a wonderful day.